Okay, guys, so we reached that point where we trained our model, and a model file basically was generated. Maybe it's not a file yet, it's a model object, yeah? It's a model in memory. We did our data pre-processing, we did our hyperparameter optimization, our model evaluation through performance metrics and so on. So we are happy with this model. And let's see, I just run this simple Jupyter notebook here just a few minutes ago. I'll not do it again because yeah, this may take a while at different stages and not good to wait, but I can tell you that's a very simple one. Let's have a look at this. It's working, no problem. So you'll just connect to Snowflake the typical way. Yeah. So just remember, we're with Snowflake ML here. Look, I will pick up. I will read a table. Yeah, a table that we registered before. Yeah, we played with this before in test diamond. Yeah, it's in a different schema. It's not in the public schema. Diamonds transform pipeline. So this is a cleaned up data set. Yeah, it's data pre-processed, values inputted, and so on. This was ready to be sent to the estimators right away. And you see here, I have a random split. Yeah. 90-10, yeah, 90% for the training data set. And yeah, it's very important. Also, I'll keep the 10% here for the test. Okay. This is my data set. So I have diamonds here with different properties, as you can see. And if you look inside, all these values are numeric. As I was telling you, all the data is prepared for whatever. Well, no, not all the data you can see here. Actually, I have clarity, I have cut, but never mind. We don't care because we don't need everything to be numeric. Yeah. But this would be, yeah, in our case, let's see, you see here, random forest regressor. This is what we'll call, so we'll have a regression problem. Yeah, regression problem to do what? We have this labeled data set. If you look here, the price is our label. Yeah, let's read directly what we have here. Just remember, we're in Snowflake ML modeling here. Yeah, we'll call this class random forest regressor. And unlike with scikit-learn, you remember, will pass in the constructor the input columns, output columns, and the label columns. Yeah. In our case here, yeah, so we'll pass the label column, the price. Yeah, this is our label, the price, and we will predict into a new column called predicted price. Yeah. Based on the input features, which are this. If you look here, these are our input features, and yeah, I think it's very likely categorical features like cut, like clarity. Let's see, cut, clarity. Yeah, they are not here. They are actually, if you see here, right before, we actually one had encoded cut. That's why we have cut OA and different other values here. So this was a one hot encoding or yeah, never mind or a label encoding or whatever. So we just reserve here numerical features. Yeah, we'll train this one. Remember, that's an ensemble learning estimator. So yes, this took a bit. This took almost 3 minutes here when I ran it last time. Nothing fancy, yeah. As I said before, data pre-processing was done before, and this was an intermediate data set ready for model training. We'll just call fit here with a training, yeah, and then we'll pass the test here for the predict. So we'll predict something on the 10% of our data, and yeah, we'll keep just these two columns. Yeah, we just need to compare to see the accuracy between the label and the predicted value. Okay, so these are numeric values. Let's see, just ignore, the versions here. Yeah, as usual, there's a bit of a version hell here. Yeah. I constantly suggest you can either use a Conda package, or yeah, take care of this in a better way in production. Yeah, definitely you have to do it. Right here, it works. Yeah, these are just warnings. You see here the price, yeah, and the predicted price. They are actually pretty close, yeah, but we don't care right now how close they are. What we care about is what to do with our model. Yeah, look, our model here uh, was generated right away from random forest regressor, we applied fit, to fit the train data, on the model, and we did some predictions right away. But we would like to save this model somewhere. If you remember, with Snowpark, we were saving this into a stage, into a name stage. If, as long as you are working with Snowflake data, you are calling Snowpark, you are deploying, your functions as a store proc. Right here on the fit, is that for sure that everything was trained in the store proc. Okay. The predict itself is very likely this created a temporary vectorized UDF here, but it was temporary. Just remember this because in most cases this is temporary, and you'll see that actually predict itself will generate behind the scenes. Yeah, we'll have a closer look at this. Will generate a simple SQL statement, a query, SQL query. Yeah, calling another predict, calling something else here. We'll have a look at this. The model predict itself. Because this is deployed as a select statement. Okay, and let's have a look at this one. It's very simple actually to use what they call the new model registry. You simply call a registry and you pass a session here, okay, just to get an interface. Uh, Through this registry, you can log a model. This means register a model. Or you can get the actual model. We'll have a better look, a closer look at the object model. Of all these objects, but for the registry, which comes from Snowflake ML registry namespace. Okay, uh, if you pass a session, by default you have a context, a current database and a current schema. Otherwise, pass also the database name and the schema name. Right here, by default, I connect to test and the and public, and that's where I want to save my models because every schema may have their own models. Okay, so this is like the models. The models are just like any other schema level objects, just like tables, let's say, just like views, just like functions and so on. Right now you have models as well. And look, it's funny because this is how you simply log a model here. This is all you need. You say registry log model, and you pass the actual model. You give the model one name. You give a version. That's important because what you actually log is not just a model, but you log also a version. If the model is already there with the previous version, you'll get a conflict if you try to override it because this will not work. So you'll have to increase the version eventually, or you'll have to drop the model and recreate it. What is returned back here is not actually a model reference as it is suggested in the code. In their code, you'll find a Snowflake, you'll find a lot of model ref, but you'll get actually a model version reference. So you'll get a reference to the model, a specific model version. Okay, keep in mind this because it's important. Transparently, you cannot use you can use only one version, from a model, but what can I say? Each model can have several registered versions. Okay, and just look at the documentation. You have different parameters. Sometimes you have still to pass conda dependencies. You may need to pass also some other parameters here. Some data to infer, the kind of values internally and so on. But so far, I just tweaked this one to get it done. And look, it's very, very interesting. If you look in the query history, you'll see that this is what was generated behind. So log model basically will translate into an SQL statement. You have a DDL, data definition language statement here, a new create model. The name of the model with version v1 from, and that's the location. And you see here from your data will go through actually a temporary stage here. This is what we have, and they will put our model first. They will load our model into a folder, into the model folder. So just remember the models themselves, and we'll see this closer later on. They became another kind of SQL objects. Snowflake SQL objects. You see here, create model, and you'll deal with the model the same way you deal with other objects, with alter model, with drop model. Remember, there is no delete model, is drop model, because this is how we deal with the SQL objects. Okay, going further, this is all you need, guys. Yeah, if just remember, you get a pointer to the registry. Yeah, that's one way of saying, okay, I want access to all the models. Yeah, in the specific current database and schema. Override database and schema if you want something different from what your current database and schema is in the current session. And then, yeah, you log a model this way. Okay. And look, right away, I can call a registry show models. And this will show me all the models in the current, you see here, in the current database and schema, in the current registry. So you have one registry basically per schema. Remember this. Just a quick, simple visual reminder where our model registry is in the ML pipeline with Snowpark ML, yeah, which is part of Cortex. As you see here, right before training, yeah, our model training phase produced a model. The model is still in memory, yeah, that's an object. That's why this could be eventually serialized in pickle format, or different providers may have their own specific format. But in any case, if you want to persist this one, this should be serialized into a specific format. And look, Snowflake did this in a very generic manner. They provided some internal registry. We don't know where exactly it's safe, how it's safe, and we don't care about this. All we care about is to call a log model. This is like a create model function, but they call it log. And the term they use is logging a model. So log underscore model will actually save a model version. Remember, if the model doesn't exist, it will be created, but it will save the model with a new version. The version should always be new, not being there. And later on, yes, absolutely, the model serving will deal with picking up using some specific model version to be used for model inference.